Hi, everyone. Thanks for joining this session today on Teen Data Science Process for Data Scientists. So this is Debraj, and we have two other colleagues. One's Carlos and Brad. They're over there. So they're also going to take turns to explain how they're using TDSP in their own organizations. And we have a companion session called TDSP for DevOps that Buck Woody is presenting on Thursday morning. So I'd recommend you check that out as well. All right. So the session goals. So I'm going to talk about TDSP, and I think the first thing I'm going to talk about is what are the challenges the data science teams face currently in their organizations with regards to process, and how TDSP, Team Data Science Process, can help in that regard. And then how organizations are adopting TDSP to deliver data science solutions to their customers. So the agenda is going to be the following. So I'm going to take about 35 minutes or so to go over TDSP objectives, components, and some aspects of how TDSP can be adopted, and do a brief demo, go over TDSP documentation in Microsoft Docs to familiarize yourself with that content and how you can adopt it, and do a brief demo of how TDSP can be instantiated and used in Azure Machine Learning preview services, which were announced yesterday. So, and then my colleagues are going to take like 15, 20 minutes each to go over their adoption stories in their organizations. Okay. So team data science process. So for reference, you can take a look at this site, aka.ms TDSP. That's going to be your one-stop shop for all of the information and references to GitHub repositories and so forth. So if you remember that, I think that should be sufficient to get you through most of the documentation and the content for adoption. So as you can imagine, the opportunity for data science impact in enterprise organizations is fairly large. And as of a survey 2 years back, 17% of the organizations surveyed at that time had a well-developed predictive or prescriptive analytics program in place, whereas the vast majority of the organizations were trying to get such programs up and running in the next 5 years, like 80% of them. However, of the organizations that were surveyed, in another study found that only 27% of the big data projects were regarded as being successful and delivering value to those organizations. So although there is a lot of promise and people perceive that data science could transform their organizations and have a big impact in which their business is becoming predictable, there is a big gap in terms of realizing that potential. So although the tools and data platforms are maturing, especially over the last few years, the data platforms have matured quite a bit for big data handling, and also the data science tools have also evolved quite significantly. But still, there's a major gap in sort of delivering value to those organizations who want to use data science as a to impact their businesses. We feel that one of the reasons that data science is not being able to impact as much as expected is because of the process-related challenges in data science. So why is this the case? So we try to explore some of the reasons. So in enterprise organizations, data science teams are often new, they're growth-oriented, they're distributed across geographical locations, and many data science teams are sort of having personnel come from different backgrounds, from machine learning, statistics, physics, so development and engineering, those sort of, all kinds of disciplines. So that sort of creates a heterogeneity due to which several organizations have challenges with regards to how to organize their data science teams and their data science programs, how to enable better collaboration within their team members, ensure quality of the projects, how to accumulate knowledge as the projects are going through in their teams, and ultimately to improve the agility of their data science projects. In addition to that, one other issue is that the intelligent application development has some unique features and complexities that's not always encountered in other software development scenarios. So all of those issues taken together give rise to some process-related challenges in data science. So even though you might have the appropriate tools and data platforms, it might not always be easy to deliver value to the business in these organizations. So why is speak up a little? Okay, so maybe I should move the microphone closer. Can you hear? Is it still difficult? Okay, thank you. So why is a process helpful for data science? But first of all, what is a process? It's a sequence of activities necessary to perform specific business tasks. And a process is useful to standardize and establish best practices. Okay. So as we all realize, the data platforms tools are changing fairly rapidly in the data science space. However, if we have an established process, irrespective of the toolkits and the data platforms that we have at our disposal, then the process can help us establish best practices upon which we can utilize whatever tools are available, data platforms are available, in order to deliver value out of the data science projects that we are doing. So we feel that data science can borrow processes from DevOps in that regard to help adopt some of the best practices that have had time to mature in the software development and operations area. So software development and operations have had time to mature, standardize, build in some efficiencies, and develop the best practices. That data science as a field is relatively new compared to that and hasn't had time to really mature and evolve and establish those best practices yet. So although you appreciate that data science has complexities, not all the steps of a data science process can be mapped out early in the when we're starting a project. There is an iterative phase that we need to incorporate within the data science projects oftentimes. But we can learn the standardized processes from DevOps and try to incorporate them into the data science projects to sort of establish a best practice and a process for data science. With some modifications, obviously. So, so DevOps is for many people might not need this kind of an overview slide, but some people in the audience may not be all too familiar with DevOps. Particularly data scientists are kind of new to DevOps overall, I feel. And so DevOps is a three-stage conversation, right? It's a combination of the culture and principles of how you break down the barrier between development and operations, and to deliver value to the customers in terms of software development often and frequently. And it's also a set of process components that I'm going to go through in more detail in the next slide. And it is a set of tools and products that you can utilize to put the principles and the process components in practice. So like I was mentioning, Buck Woody, in this other session that's mentioned in the top, the bottom right corner, he's going to go a bit more detail into DevOps components. But I'm going to say that in terms of the DevOps process components, these are the things that we feel are important. So infrastructure as code, automated testing, continuous integration, continuous deployment, release management, app performance monitoring, and so on. So data scientists often are not really thinking about these aspects as much as they should, perhaps, from the very beginning when they start exploring data and develop a model. However, I think keeping all of these things in mind regarding what is an entire process from start to finish in terms of when you conceptualize a business problem and define it as a machine learning problem, to the point when you have a deployment of the model and the model needs to be performant and both in terms of the accuracy as well as the runtime. I think if the data scientists are thinking about these aspects from start to finish, at the very time they conceptualize a project and initiate the project, I think that's going to be really beneficial to to the data science project execution and delivery and operationalization. So that's why we feel the adoption of DevOps process components into data science could be really helpful and beneficial for data scientists. And based on that, the objective of TDSP is the following. So we want to integrate some components of DevOps with the data science workflows that many data scientists are familiar with to create a process that will make data science work more collaborative, will improve quality and productivity of the data science teams and the projects that they are doing. And integrated into that, we have to have some work planning and execution framework, which we think Agile would provide. So with Agile, we can put a framework together for data science project execution and delivery, but include components from DevOps as well as and the data science workflow, which typically involves data ingestion, data exploration, modeling, and the like. So based on that objective and those kinds of thinking, we have developed the TDSP components for data science teams. So these are the primary four components of team data science process: the standardized project lifecycle, project, project structure, templates, and definitions of roles, uh, infrastructure, and reusable data science utilities. In the next few slides, I'm going to take some time to sort of go through these components in a bit more detail. So the, we have a standardized data science life cycle, which looks like this. We feel that most data science projects would fit into this kind of a life cycle. Now, there are lots of details in each of these stages from start of a project to business understanding and going to the next steps in terms of data acquisition and understanding. Sometimes that itself is sufficient, and what the businesses are asking for in terms of getting more insights from their data and back into the business owners. But more often, we also see that after you have gotten some initial understanding of your data, you have explored the data, you need to develop some kind of predictive models that the business is asking for, and then ultimately have deployment of the models so they can be consumed and operationalized and so forth. So this is a very high level overview of what a data science lifecycle looks like. So there are lots of details here that perhaps you can't really read, but each of these steps, for example, the modeling step has feature engineering, model training, evaluation, and so forth, and then further you can divide them into smaller chunks of work. But however, these stages of the data science lifecycle should be able to sort of have most of the data science projects in its scope. So utilizing the data science life cycle sort of as a foundation, we have developed some templates that help in figuring out how you would execute and deliver a project to your customer, for example. So let's take one of these phases, business understanding, for example. Then within business understanding, we have templates and deliverable documents that people can adopt and utilize in their own projects. And you can also set the expectations with your client or customer with regards to what are going to be the deliverables at each of these stages of the data science lifecycle. In some cases, you might need to iterate and go back and start the process. For example, if there isn't sufficient amount of data for you to be able to build an accurate model that needs to, then you need to feed that back to your customer and reinitialize the process of collecting more data to answer your machine learning question. But overall, you can maybe structure a project from the very beginning and set expectations regarding these are going to be the stage deliverables for, these are going to be the kinds of documentations. And TDSP provides templates. I'm going to come to that in a little bit of time, where in an open GitHub repository, we provide default templates that you can get started with respect to your problems. So we provide two kinds of templates. One is the template for that you can clone from a GitHub repository and structure your project. For example, I think you might not be able to read that very clearly, but it provides a structure with respect to how you should organize your documents, your contents for code, deliverable documents for your customers, some sample data that you would need to ship with your code in order to test your code and so forth. So we have some structure and guidelines regarding that. In addition, we provide default templates like the project charter, scoping documentation, what kind of questions you really need to ask at the very beginning of a project in order to be able to articulate the business problem very well and translate the business problem to a specific machine learning problem and so forth. So our documentations are prepared in a way that it helps you to discuss these issues with your customer and get to a point where you can really start filling out this document and develop that template and flesh it out with respect to the details of your own project. There are guidelines with regards to how, in an enterprise organization, how you would structure a data science team. So a data scientist, by himself or herself, might not be able to deliver all the capabilities that are required from start to finish, from data pipelining and architecture all the way up to operationalization of the model in a very performant manner. So in that regard, and also there are aspects of business, the project management, how do you define the business problem and so forth that other people could help that better with. So we have some guidelines with regards to how you can structure a data science team, what the roles and tasks should be. So we have like data scientists, project lead, team lead, and those kinds of things, and the articulation of what these roles are and tasks are that are need to be performed are also present in the TDSP documentation. But I think at a high level, you need to consider perhaps two kinds of roles. One is more related to project management and governance. Tasks could be like setting up Git repositories, setting up Azure resources that enable you to compute, and data resources that enable you to execute the project. Um, on the other hand, scientists and engineers, they could be involved with actually developing the models, understanding the data, designing the data pipeline for data ingestion, and so on. Although we provide these kinds of guidelines, but remember, I think for every specific organization, they have their own structure and prefer their own way of structuring teams. So we provide flexibility of how this could be changed and adapted to the organization's needs. A little while earlier, I was talking that we need to, in addition to these templates, etc., we need to provide some kind of working framework which enables you to iterate through quickly, define the work steps that are needed to execute a data science project from start to finish. We have developed some agile work planning and execution templates that are specific for data science. This is a template that we have designed, for example, on the right-hand side. No, we have agile work planning and execution template that corresponds to the data science lifecycle stages and so on. So you can plan your work in agile. This is with done in Visual Studio Team Services using a Scrum framework. So iterative Scrum framework, or defining sprint for 2 weeks and so on. So we have this kind of templates that one can also utilize once the project gets started. How do you plan the rest of the work in the project and execute through step-by-step manner to deliver the project to completion? So for people who are managing a group of projects, one can also summarize the different activities that are going on, who is doing what kind of activity in which stage of the data science life cycle, how many times is the code being checked in, for example. We can do some summarizations by integrating Visual Studio Team Services to Power BI to create some dashboard to manage and also observe how the work is going on across different projects in the team. So now we talked about the template structures and so on, which involve the Git repositories, documentation templates for work planning and execution. The next thing I'm going to talk about is the infrastructure that you need to provision in order to get started with your own work. So in an organization where there are many data scientists, and you can imagine there could be a many-to-many mapping between the compute resources, data resources, and the people who are actually executing the work. So in that kind of a framework, we provide some guidance regarding what kind of infrastructure do you need to provision to get started efficiently, what kind of storage, compute resources you could utilize, and so on. In particular, the data science virtual machine is a very popular tool with data scientists, and that's the tool we recommend. It comes with a Spark and a bunch of other tools that are already pre-installed. So you can use this as a very efficient development environment and get started very quickly. And however, if you need to scale, because this has Spark, for example, you can scale it up into HDInsight clusters to multiple worker nodes and distribute your workload that way. So just remember, this is the compute and data resources are not necessarily an integral part of the data science process. The process has its own purpose. to establish best practices, give guidelines, and so forth. However, if you prefer utilizing compute resources and data resources on your on-prem servers, for example, you could utilize them instead of cloud resources or data science virtual machine. You could switch with your own virtual machine on-prem or something to swap out the resources that you would include in your data science process and redevelop the guidelines with respect to your specific organization. So, and in addition to that, one other kind of infrastructure that you need and is a Git repository. And the Git repository can be hosted in GitHub or Visual Studio Team Services. But this really provides a framework on how data scientists would do collaborative work, how they would merge their work from local to remote and so forth. So we provide a detailed guideline of how that should be done. It's nothing new, but many data scientists are not really accustomed to working in a very collaborative environment where they do joint development of code and merge their code to main and so forth. So, but this kind of guidelines help the data scientists get up to speed if they're not already there, and sort of enable a common framework that they can adopt within a team to do work collaboratively. So we also provide this the template, and so that the purpose of some of these templates is to make sure that there's standardization and uniformity, which ultimately should improve the efficiency of how a team is delivering and executing projects if there is uniformity and standardization. So one benefit of using Visual Studio Team Services and the Git repository is there is the fact that you could connect your development work with your work planning in Agile. So once you start a work item, for example, in Agile, you can connect it to a new Git branch, so that way your code and work planning is tied together properly. So in addition to the infrastructure and templates, we also provide reusable data science utilities. So the purpose of these are twofold. One is to make sure that the data science work can go forward efficiently. So we have some standardized utilities that you can use project after project. For example, in terms of data exploration, understanding the data much deeply, try to find out what is the missingness in the data and so forth. That is usually a step that you take on at the early stages of a data science project before you start doing the modeling. So we have this utility called Interactive Data Exploration and Reporting, available in Python, R, and Microsoft R Server for big data. And the outcome is that you use one tool across your project to do data exploration, and then ultimately, once you're happy with how the data plots, etc., look like, which you can do in an interactive mode, you can save some of this information in a standardized report. So that report can be very helpful as a deliverable to your customer. That this is in the first phases of your business. After business understanding in the life cycle, the second phase is data ingestion and understanding. So that could be one of the deliverables for your customer in that phase of the life cycle. Another tool that we have published is the automated modeling and reporting utility. This is available in R at the moment. What it does is we're using a variety of different algorithms. It will quickly develop a modeling report for you, where it has done hyperparameter sweeping, model development, compared the accuracy of different models, given feature importance, for example, for different models. So, and ultimately generate, again, an HTML report which can become a deliverable to your customers. For example, the automated modeling, the top panel here is that automated the report that was generated with some summary of how the models were performing in your data set. And the bottom two panels give you information about the accuracy of the model in terms of the expected versus the actual versus predicted values, as well as the feature importance of the different kinds of models. Okay. So in addition to the 4 components, lifecycle, template, structures and roles, guidance regarding infrastructure, and finally, the usable code, we have worked out samples that we have published in a variety of platforms using Azure Machine Learning, HT Insight Spark, Hadoop, SQL Server with R and Python, and so on. The purpose of these are to sort of give you concrete examples of how finished projects would look like with code and documentation. And so that go much beyond templating and provides you concrete examples for adoption with your use cases. So we have an extensive series of these available in our documentation uh, with GitHub links and so forth. So finally, I think I want to spend a couple minutes talking about how you can adopt TDSP within your organization to improve the efficiency. So in this case, what our observation has been is that depending on the heterogeneity of an organization, the maturity of the data science teams, you might need to take a stage-wise approach in order to sort of ease the barrier to entry and get the maximum value as soon as possible. So some of the practice, this is a lot of wording, and I put this detail there so that once the slides are available, you can take that the slides and read through it in much more detail. But what I would say is some of the early adoptions, the benefits would be from utilizing Git repositories, standardized structures, both for directory and how the directories should look like, and also the templates. So standardization using collaborative approaches for development. So these are some of the things that can give you a lot of benefit early on, I think. And then developing your own utilities and tools, standardized tools that would take more time perhaps, but once you've done some projects, that those tools can also be integrated into some common repositories for your team. And in sort of more mature stages of adoption, you can consider sort of developing automated testing for your testing framework, code review amongst peers, linking Git branches to work items, and so on. We have had several teams, internally and externally, adopt team data science process for the executing and delivering their data science work. We have several teams in Microsoft, including consulting services from whom we are going to hear later today, and several mature teams in cloud, AI, and research groups, Windows, and so forth, and also external customers such as our partners such as New Signature, Blue Granite, and so on. So we are going to hear some of the adoption stories later on. I think that's going to give you a good feel of how TDSP is put into action and with some modifications may be adapted in different organizations. So in summary, what I'd like to finish up with in this section is that the fact that there are process-related challenges in data science that I think we need to address in addition to the tools, data platforms, and so on. Otherwise, it is the expectation is going to, the delivery is going to lag behind expectations somewhat, what data science can provide to their organizations. And hopefully with the guidelines along with the components that we have developed for data scientists, some of these challenges can be addressed, overcome, and so forth, and and the efficiency can be improved in their data science organizations. So with that, I have like maybe 5 minutes to show you, 7 minutes to show you some demos of what the content looks like in terms of our documentation, where you could find all these materials, and also a demo of how you can utilize it if you're using Azure Machine Learning, preview services that were announced yesterday, how you can easily use TDSP in Azure Machine Learning. So first, I'd like to walk you through a little bit in terms of the documentation. So the primary source of documentation would be this. So if you go to ak.ms/TDSP, that will lead you to this documentation landing page. Okay. So once you're there, so this is the same page as this one. So overview lifecycle, the project structure will get you to a GitHub repository where you have the project structure. You can clone that project structure for your projects to get started with your own projects. So this is a template that you ultimately need to fill with your project-specific information, but this is a template that you can clone. Okay. So in addition to that, there are a group of what are called tutorials. These are essentially the worked out end-to-end examples or samples that you could utilize from Azure Machine Learning, a preview which came out yesterday. We have some worked out samples here also one of them I will go through it in a bit more detail, although time is short. But in addition to that, we have a variety of Spark, Hyben, Hadoop, USQL, and so on. So this should give you enough of many samples that, depending on your platform and how you would like to adopt TDSP, these are resources that would be helpful for you, we believe. And we have how-to guides, how to use, how to provision data science environments on Azure, how to use TDSP in Azure ML with preview services, and in terms of resources, we have the TDSP utilities repository where you can clone the tool, the data science utilities I was talking about for modeling and data exploration. You can clone those also from this GitHub repository. So this TDSP chunk of documentation is integrated also with AML, Azure Machine Learning Preview Services, where you'll find similar content through that chunk of documentation also. So you can go and take a look at how-to guides, and you have how to structure projects using TDSP from Azure Machine Learning. And there are some examples also, real-world case examples. There are some that are classified as TDSP projects. In that case, those projects have strictly followed the TDSP structure, templates, etc. So you can take a look at what those would look like in Azure ML. So that's all I'm going to talk about in terms of documentation. So what I'd like to show you is, yesterday, a bunch of services that were announced in preview form for Azure Machine Learning Experimentation Services, Model Management Services, and the Workbench. So we have utilized these three in particular, and I'm going to do a brief demo to show how you can instantiate TDSP structure and templates directly from the Azure Machine Learning Workbench. So you obviously need to have an account and the services in your account and your subscription. But then once you have the Workbench, which is a desktop application that's connected to your model management services and experimentation services, what you could do is when you go and open a new project and start creating a new project, what you would see is there's a group of, say, so that's your TDSP project that you're probably starting to initiate for your customer, maybe based on a TDSP template. And then when you search for TDSP here, this TDSP example is there for you to instantiate. So what this is doing in the background is pulling that GitHub template and structure that I just showed directly into your workspace and creating an empty project. Now, there is another project here, which is a filled out project, which you could also clone and create your own project. So this will give an example of a finished project looks like with all the documentation and so forth. But for a new project that you're trying to initiate, you could do that. And that should bring a TDSP dashboard, all the structure, etc. that I was talking about will already be there for you to fill out and get started with your own project. And there's in terms of documentation, there's deliverable documents and there's some optional documents. So essentially, these give you the structure templates, etc., that you would like to do directly from Azure Machine Learning. Then, in terms of the examples in Azure Machine Learning, we have released 2 at the moment since yesterday. There's one, actually, maybe I should go through the slides here. And due to lack of time, maybe you could explore these things in much more detail, but I don't have time to go through it. Yes, please.
Hello. So I understand the name is data science, but seems like a lot of this is applicable to a big data project. Can you please highlight where do you think that this will be appropriate, where a big data project, data warehouse will be out of scope, given the framework to design?
So I'm not sure if it is out of scope. I think you're right that big data projects could also fit into this framework. The precise architecture and the infrastructure that you might want to use may not be strictly within the guidelines that we have given at the moment, and that's not necessarily saying that it's out of scope. It's just the amount of content that we have put together is specifically for data modeling and so forth. But other projects that involve big data are also within the scope of this.
Well, the thing is, there will be more infrastructure decision,
Yes.
infrastructure management. Do you think that
Uh-huh.
could be handled, or
So if you go to TDSP documentation, there is within the documentation you will find some drop-down menus for taking decisions of what kind of structure you would like, infrastructure that you would like to provision, and you could get some guidance there. But I'm not entirely sure that all the guidance you would need regarding an infrastructure and an architecture will be available within the TDSP documentation. That's our ultimate objective, is to make sure that all the information that a data project would need is there. But at this moment, quite a bit is there, geared much more towards data science projects overall. And but guidelines regarding how to provision HD inside clusters, for example, for big data projects, those guidelines are also there that you could find in the documentation.
okay?
Yes.
What section can you give the? Kind of over perfect.
Yeah, so yeah, I think bug session is going to be helpful. But like I was saying, that our samples cover a lot of different architectures and data platforms. With virtual machines, HD Insight, Hadoop, and Spark clusters, SQL Server, use SQL, and Azure Data Lake. So we have certainly a big data covered. But within the scope of the big data samples that we have shown modeling always. So that kind of all makes it a data science project.
If nobody else has a question, I have a second one. It seems like the role of the orchestrator of this framework will be the equivalent of a Scrum Master. Do you see this way?
So today, I mean, it depends. Again, every organization works differently. So for some organizations, perhaps there's a PM or who kind of is making the scrums and so forth. But oftentimes in small teams, the data scientist or maybe a couple of people can take ownership of that. It's just the fact that you have to internalize and understand what a scrum is, how that works. But once you've done that, then I sometimes, as I'm a data scientist by training, I do it myself, for example, and work with a couple of colleagues with regards to that.
Within the framework, do you have a role and responsibility,
Yes.
just like the architect versus the data science versus the tester? Do you have that kind of guidance?
We do have some kind of guidance like that with regards to specific roles and tasks.
Well, great job.
And that's not to say that that covers everything, and every organizations need to adapt and change.
Thank you.
So yeah, in the interest of time, I'll just move forward and take any other questions maybe after everyone's done. So go into the documentation, and these are some of the talks that you could take a look at, because there are a bunch of talks in Azure Machine Learning Preview Services, and we have tried to integrate some of the TDSP capabilities with that. So the more you're familiar with these kinds of services, I think you'll understand better also how to use TDSP in the context of these new services. I went through this one. This is also from Azure Machine Learning. So, okay, so the last slide I have is this, which kind of delves into a little bit of the samples of what is available. So we have a lot more details. We have one, in Azure Machine Learning, we have one empty template, right, that you can instantiate to get started with your project. And we have two other samples. One sample is with sort of a how-to quick start type of sample, which is the US income classification. That's an end-to-end finished project that you could take a look at and really execute quickly and sort of get a handle of things. There's one other project which is much more comprehensive. It uses natural language processing and deep learning in Spark and DSVM. It's a very extensive project, complete with operationalization. So if you have a scenario like that using Spark and deep learning, that gives you a much more detailed information of how to sort of initiate and complete the project under those kinds of frameworks. So with that, I'll finish up, and I'll leave it up to my colleague from Microsoft Consulting Services.
Okay. Thank you, Debra. Okay, hi everyone. I'm Carlos Medina. I am from the Microsoft Consulting Services organization. In particular, I am CTO architect for the data and AI sub-organization in Microsoft. Okay, so what is Microsoft Consulting Services? So, you know, Microsoft is very big. We have different organizations. One is the product groups, like Debra is belong right now. Another one is the EPG organization, but also we have enterprise services. And we, in enterprise services, our primary objective is to try to deliver solution to our customers, okay? So I am here, so in this particular, so we have a lot of people here, okay? It is like 21,000 of people around the world. We have people in America, in EMEA, in India, IGD. We also have people in APJ, okay? More than 191 countries, 46 languages, 35 global partners, okay? So as you see, we are a big organization, and the idea is to explain how we are using TDSP to implement data scientist project in our customer. Okay, so this is something like addressing also your question about how also people are using this particular methodology or process. Okay, not only for data scientists, but also we as a Microsoft as a service consulting organization, we need to use this process in particular to try to achieve success in the delivery in our customers. Okay, so consulting services. As I mentioned, we try to bring all of our knowledge in our customer to provide solution. What kind of solution? Modern workplace, business application, application and infrastructure, and the most important one is, at least for me, is the data and AI. And how we work in the data and AI. So this is the kind of thing that we provide to our customer, okay? In the data and AI organization, we provide advanced analytics, IoT, and also AI solution to our customer to give them all of the potential to get more insight about their information, okay? Try to cover different business cases, scenario to bring the potential, okay? But also business intelligence, data insight, and visualization using the different technology that we have in Microsoft. And this is very important. Why? Because as you know, maybe in the past we only use a Microsoft tool, but now we are also using open source technology like Spark, Hive, Hadoop, Kafka, Storm, etc. Okay, and finally the data plan for modernization. And one of the things that we have seen is how the data analytics platform in a modern definition is working right now. Okay, so we have the fundamental analytics. Okay, where we try to ingest, transform, store, and aggregate information to our customers. But moving forward, now we are in the advanced analytics world in some way. Okay, right now, where we try to include semi and unstructured data at high volume of information to provide the best insight to our customers, okay? But moving forward, the data culture, decision and actions are driving now our customer. And this is why we are moving from historical to predictive now to prescriptive analytics, okay? And finally, the data architecture, now we are in the digital transformation era, okay? So we need to put together all of these concepts in our customers. As I mentioned to you, we are a consulting service company, so we need to try to go to our customer, be on site with them, work with them in order to transform the actual business, go into this digital transformation area that everyone is looking for. Okay, so using all of this technology that we have, using all of these processes, we need to bring success to our customers. Okay, so what is one of the major challenges that we have seen in this organization when we try to talk about data and AI? Okay, so one of the most important, one of the issues is that talent with no strategy. Okay, there is a lot of companies around the world that have a lot of talented people. Okay, brilliant data scientists, really good data scientists, or really good data engineers that can process a huge volume of information very quickly using big data technologies, okay? However, there is not a structure, there is not a strategy to help this organization to put everything in place. Also, right now, we are moving, instead of using servers, now we are moving into services. What does that mean? That means DevOps operation, DevOps strategy, DevOps principle in our organization. Okay, so what we have seen is that most of the people and most of the organization is still struggling with servers, trying to personalize servers instead of convert everything into services, okay? So also we are also helping our customer moving from servers to services, okay? And not data culture. Data, you know, everything is about data. if you have data, but if you don't know how to use the data, you don't have anything, okay? So everything is about data. So what about the culture? What about data governance? What about the different aspects that you need to take care? What about security? What about the semantics? What about the dictionary that you need to put in place in your data culture in your organization to bring the best of the data that you have, okay? It is not only about to have data, it is also about how you are using the data, okay? Finally, reaction versus strategy, okay? So let's stop working in reaction everything. Let's try to do more strategy in our customers. So this is what we in consulting services try to bring the potential to our customer, try to organize everything, try to work with our customer in this goal, okay? So if you see, everything is about governance, everything is about management, everything is about integrity, protection, etc. And in this way is where we are using TDSP, okay? TDSP is helping us to organize our job in order to bring the best to our customer. As Deborah was mentioning before, TDSP is a process, okay? TDSP, you need to see TDSP as an agnostic process that you can use in every organization using any kind of technology. It is not that you are using big data or just a small platform that you want, or it is not that you are using only Azure Machine Learning or R over Spark or Python or whatever is the technology for data scientists. It is agnostic. It is a process, okay? So what we have done. So internal in Microsoft, we have something that we call the SDM, the Service Delivery Methodology. Service Delivery Methodology is how we guide to our people to deliver projects, okay? Agile projects, waterfall projects, and also data scientist projects. In this particular data scientist is how we integrated TDSP in MCS, in Microsoft Consulting Services. So what we have done, so as mentioned, so as Deborah was mentioning, so TDSP is a guidance process. We have different steps for, in particular, business understanding, data exploration, data modeling, and also operationalization. So we try to put everything as a framework to give to our consultant, architect, PFEs, everything that so they can use in our customer. Okay, so if you see, so we have in this one in particular we have 4 steps, and each particular step is a framework. Okay, so when our people go in our customers, they are using TDSP, so they use this particular framework, they use this particular documentation. So if you see, we have one template. Let's say this one is for business understanding. In this business understanding, we have all of the activities that need to be in place in this particular step, but also categorized by the different roles that we have. We have MCS data scientists, we have MCS data engineers, but you know, data scientist is not only about us, it's also about our customer. So we also have which is the role that we need from the customer over there, and what are the particular activities and responsibilities that we have. We also have a rating metrics that I am not showing you, but also we have the different responsibilities that we have. I will show you in the demo after this one, okay? And very important is what? You know, we are consulting, so we go in our customer, but our customer is paying for our services, okay? So it is really important for our customer to see how we are spending the time, what we are doing. So this is why every step has the different deliverables based on the TDSP process, okay? So this is why you see we have 3 particular deliverables in the initial step, okay? About what is the business objective, what is the data sources that we will use, and also what is the data future that we are planning to get over there, okay? In this way, as soon as we finish the initial step, we can show to our customer, okay, so this is the information that I collected. This is how we are working with you in order to solve your problem, in order to try to get everything in place for you defining this particular business objective, okay? After we finish this one, we also have a checkpoint with the customer. As you know, data scientist is iterative. That means that we can move forward or we can go back depending on how much information do we have, depending on if the data quality that we have, depending about the business variable that we already have available for that particular space, okay? So after each particular step, we have this particular checkpoint. So this is not only, so besides the business understanding, we have also created a template for the data exploration, okay? And also, what is the different steps, what is the different activities, what is the participant, what is the role that we have. And in this particular step, so it's where we start working together between the data engineers and also the data scientists in order to, because data scientist is only about, okay, what is the data, what is the modeling, what is the statistical model, what is the quality, etc. But they don't put many effort about, okay, what is the architecture solution for this particular customer, okay? What is the operationalization? Because at the end of this particular project, I need to operationalize everything. I need to retrain the model. I need to ingest the information in a frequently way, okay? In this way is where the data engineer comes to the picture in some way and start working with the data scientists trying to figure out what is the solution architect that we will leave for this customer. Why? And this is important. You see, we are not pointing to any particular technology. We are agnostic, okay? So if the data scientists decide to use Azure Machine Learning, so the data engineer or the solution architect will start working with them about how to structure, how to operationalize the Azure Machine Learning model in the future. If the data scientist decides to use Spark, so the solution architect start working with them how to structure, how to put all the components in place in order to operationalize the Spark environment in the future, okay? So this is I will say that this is the good about this particular process. We are not pointing to any particular technology. We are completely agnostic about the methodology, about the technology. And also about data modeling, we also have framework. We also have deliverables to our people, how to use this particular data modeling framework, how to use all of the activities. We have also implemented quality gates that people need to take care in each particular step. Okay, so before to go into the checkpoint, into the last checkpoint with the customer, they need to make sure that they already complete all of the quality check or all of the quality gate, so they can go with the customer and say, okay, so we complete this, we already have this information, or we are missing this one, so we cannot move forward, okay? And also we have the deployment and operationalization. And this is important because, as you see, we already have four different steps, but we put more focus at the beginning in business understanding, data acquisition, and also data modeling before moving into the operationalization. We only move into operationalization when we make sure that we reach the accuracy of the model that the customer is expecting, okay? If we are not able to reach the accuracy, but we already have all of the information to explain the customer why we don't have an accuracy about 90% or 95%. So we already have all of the documentation, all of the proof that we show to the customer, okay, this is why we are not able to achieve this one, so maybe we need to go back to the initial step in order to complete every step, okay? So this is the first step, okay? Now, what is the second one? The second one is about TDSP in a modern approach, okay? So Deborah was showing to you about how they are using TDSP with their own work items, okay? However, when you go into a customer, it is possible that the customer already have a predefined methodology like Scrum, or maybe Agile, or maybe in some situation Waterfall, but Waterfall is almost there, so only talk about Scrum or Agile, okay? So in this way, again, in some situation, we need to get aligned with the customer, okay? In this particular way, this is how we are mapping TDSP into an Scrum methodology, for example. So if you see, we are using epics, we are using features, we are using PBIs or history, we are using testing, okay? That this is the language that the customer is understanding right now. Maybe in a process, we can evangelize our customer to provide a better structure, but at the beginning, we need to work aligned with the customer, so the customer will understand how we are working and what is the different steps that we are providing them, okay? So in besides to how we are structuring, we are also using Kanban in order to show the progress to our customer. And this is I will say, a particular Kanban dashboard, because if you see, we are using 4 different steps, but we cannot move the different steps to done until we already know that we already reached the accuracy that our customer is expecting. how this help our customer. This help our customer because our customer will say the progress. We'll also say, we'll also understand how the different roles are working, how much effort the different roles had put into each particular step. And this is repeatable for every project, for every data scientist project. So every data scientist project has this particular structure, so the customer will feel that, okay, I already have the appropriate people working on this one. This is the total effort that they have consumed, but they already have this proof, okay? They already have deliverable this particular document, so they are working well, but maybe this is a challenge project, so maybe I need to invest more money on them, or maybe, okay, this is a stopper, maybe we need to stop and maybe change our business objective, okay? And finally, a little more graphically, this is how we try to tackle this one in our modern approach, okay? So we use, I will say, a pre-sprint, or in some situations we call this one a rapid envisioning workshop, where we start working with our customer about the business understanding. We execute this one with business architect, or maybe or business architect, or maybe a business SME from the customer. But as soon as we move into the sprint zero and sprint and the different sprint cycle, we try to start working in this iterative solution, or in this iterative iteration with our customer, okay? And at the end, as soon as we finish, so we go into the operationalization steps, where we try to put everything together, okay? Now, let me go into I would say a quick demo, okay, to show you what is TDSP. Okay, so this is this is SDN. This is the service deliverable methodology that we have. This is a portal, okay, this is a website. So if you see, if people come here, they will see the TDSP, and if they click in any of these particular steps, they will be able to see the complete methodology, all of the steps that they have, okay? If they click in any of these, in any of the activities, they can get more information, okay? They can get more information like what is the description, what is the business objective, what is the quality gates, what is the deliverables, activities, what is the entry criteria, and also what is the exit criteria. From the governance point of view, if you see from the management and governance point of view, we are giving everything to our customer. And also, something that we are doing right now is in some situation when the customer feels okay with this process, with the methodology, we are giving all of this material to our customers so they can adapt the TDSP internally in their organization. And right now, we have done this one as a consulting company with a couple of customers. I will say more a couple. I will say maybe 10 customers around the world, where we are giving them all of this material so they can continue using all of this guidance internally, not only with us, but also as soon as we leave the customer, they will continue using TDSP, using all of these particular practices, and also the projects and templates and documents that we have, okay? But not only this one, but also if you see, we also have responsible, we also have a raising matrix, and if you click in any of these particular link, I will open a Word document with a template about the deliverable that we need to provide to our customer, okay? It's opening, okay, see. This is data and feature definition. This is the template that we already have prepared to our people on the field that they need to provide to our customers, okay? So, okay, so this was about the demo, and finally, I just want to make sure that, see, this is how we work right now, okay? This is a overall picture about our data analytic platform, okay? If you see, we are agnostic. We use whatever we need to use in our customer. If our customer is feeling okay using Spark with R or Python, so we are using Spark with Python. Azure Machine Learning, only Python, only R, using the new machine learning server, okay? We are agnostic about the technology. We just provide the best to our customer in order to bring them success in the different projects, in the different data scientist projects, using TDSP, okay? So thank you. Now, Brad will talk about news.
Thank you. All right. So my name is Brad Johnson, and I'm a senior data scientist at New Signature. We're a Microsoft partner, and we're actually 100% focused on Microsoft, and we've been involved. Okay, we've been involved in executing data science projects since 2014, and really bring a lot of passion to it. We're a full stack Microsoft partner, but I'm a member of our IoT and advanced analytics team, which is focused on helping organizations understand and apply the technologies that Microsoft is bringing to the market. So I'm going to start us off with a little bit of a mental model. Earlier, Debraj was talking about the diversity of projects as a challenge in data science. It's also a major opportunity, and we like to place the projects that we're working on within a broader context, and we use this mental model of a connected enterprise, and that's an organization that is able to acquire data from all of its operations, translate that data into insights, and then take action on those insights to do things like run their operations more efficiently, make their products in a more consistent manner, understand how those products are being used, and even make their products behave more intelligently, as well as getting insights into how customers are behaving, how they're engaging with the company, and how they're using the products. So when we think about a connected enterprise, that's a wide variety of different use cases where something like data science could add value. And what we like about the team data science process is it allows us to take a process, a methodology, a set of tools and technologies, and apply those to a wide variety of different use cases. So it helps us make sense of what can be a bewildering environment of lots of different technologies, lots of different scenarios, lots of different use cases, and having a consistent structure and a set of common pieces of language to establish a common understanding is extremely useful. So here's another mental model, and this is meant to explain a little bit about how we incorporate the team data science process into a larger structure that's designed to help make sense of all these different use cases, all these different capabilities. So we have here the 4 pillars of IoT and advanced analytics. On the left there, we have things. So those are pieces of production equipment. They are products. They are people. They are servers. Anything physical in the physical environment, that's what we're talking about there. We also have connectivity. That's the means by which things are communicating with systems like the cloud. We have data, which is obviously a foundational component for everything we're talking about here. The reason we connect things is to get their data and to work with it and to make sense of it and to translate it into something valuable for a business. But really we see these first 3 pillars as foundational. They are absolutely necessary and crucial, but what we see is that the true value of building systems like IoT is in the analytics. It's in translating that data into something useful, something valuable. It's in translating that data into an insight. And then even more importantly, it's taking that insight and translating that insight into an action. It's controlling something more effectively. It's making a decision that's based on that data and turning that into something valuable for a company. So this analytics pillar is where I spend my time, and it's where we apply the team data science process. So this is just meant to give you a sense for where the team data science process fits in for us when we think about customers and we think about new projects. Okay, so Debraj showed this slide earlier. I love this diagram because it helps me explain to everyone that I deal with exactly what we're doing and why we're doing it. I find that if I'm working with a new customer, or even if I'm working with colleagues within my organization, oftentimes they don't have a background in data science, they don't understand all that goes into it and how to structure a project. And so a diagram like this and the phases that it describes are incredibly useful for establishing that common understanding and a common language about what we're doing and how we're doing it and why that's valuable. So we've actually taken this structure and we use the terms, actually we've adapted it a little bit. We use the term problem definition rather than business understanding. It's just a little bit broader and more specific. We find that just resonates just slightly better with our internal people in our organization. It's just an example of how to customize some of this. We don't have to take everything exactly as it comes in from Microsoft. You can adapt it, and I think that's one of the strengths of the process. But we actually borrow the terms here and the activities when we build out a project structure and when we explain to customers what phase we're in and what we're working on. This is immensely useful to show not only what the phases are, but how they relate to one another. And we can illustrate iteration by looking through these, through the diagram and the arrows that explain the order of operations here. Okay. So here's another slide that should be familiar. I think Debraj presented a related one. But in addition to that common language and those ideas that, that we can explain not only to our customers, but to people internally, to help everyone understand exactly where we are, what we're doing, why we're doing that, we can actually tie those project phases to roles and to project tasks and to artifacts. So that allows us to stay integrated and to be efficient about what we're doing and in what order we're doing it, and everybody knows what to expect and when, and this keeps everybody on track, and it's very visible what our project, how our project is doing and where we are. And actually, the recent announcements about Azure Machine Learning and the Workbench demo that Debraj introduced you guys to, that's really taking this to the next level, where instead of having a project structure that is sort of a concept, you have to maintain, we've got our project tasks and our deliverables, and here's our schedule, and over here we've got our working environment and where we're actually doing the real work. Now those two things are really married in a much more integrated way, and things are going to be even more efficient, even more integrated with that new tooling. All right, so really the main thing I'm here today to talk about is a specific example where this methodology was applied and was found to be useful. It's kind of a fun use case. I tell the story a lot. We call it the Internet of Twizzlers. So I did this project with Hershey. I don't know if you guys eat Twizzlers. They're delicious. But what we wanted to do was find out whether IoT and machine learning and taking a data science approach could make the process of making Twizzlers more efficient. So that was kind of our mandate. Twizzlers is a batch process. So when you make Twizzlers, you cook up a big batch of what turns out to be kind of a big red mash of Twizzler raw material. And that batch of material is pushed through this thing called an extruder, which you see right here. And that extruder, you can think of it kind of like a tube of toothpaste. And it squeezes out that red mash into the familiar rope-like Twizzler shape with those twists and ridges. And our effort was focused on looking at that extruder and trying to see what we can do to improve the manufacturing process for Twizzlers. So I'm going to present this in the order of the phases that I showed before. So as I mentioned, we use the term problem definition rather than business understanding. They're perfectly exchangeable. They really mean the same thing. But we had to start with a really clear definition of what it is that we're trying to achieve. So the idea of let's make Twizzlers in a better way is a little bit too vague. We need a very specific problem definition that we're going to use to make sense of what can be a very complicated problem. So making that problem specific, if you've looked at a bag of Twizzlers or really any product in a grocery store, you'll see that it has a net weight listed on there. I think that's a 32-ounce bag on the slide. And that weight number is actually very important to a company like Hershey as it produces Twizzlers. If Hershey says that the bag is 32 ounces, it must be at least 32 ounces for Hershey to legally be able to sell it. So variability in the manufacturing process is expensive for Hershey, because if they produce a bag that's underweight, if they make a 31-ounce bag or a 31.5-ounce bag, they can't legally sell that on the market, and that's pure loss. So to account for the variability in the product, Hershey actually creates a target for their machines. That's that orange line that's actually above the line. So if the blue line down below, that represents 32 ounces. The orange line above that represents a higher level that the machines are set to produce to account for that variability. So the gray line is the actual weight. The blue line is the weight listed on the packaging, and the orange line is the higher target that's set to account for that variability. So variability is costly. It's costly above the line because Hershey is giving away product for free. It's costly below the line because if that line ever dips below the blue, then we've given away a bag, we've lost a bag, and are no longer able to sell it. So our goal was to use predictions of product weight to modulate the behavior of the extruder. So if we're producing too much, we want to slow that down a little bit. If we're producing too little, we want to speed it up a little bit. But actually, the idea of iteration here is relevant because when we started out, our goal was let's predict the weight of the product. And it turned out to be more useful for us and actually more achievable given the data that was available to predict the direction of that change. Rather than predicting we're going to produce 32.3 ounces, it was more useful for us to say we're producing too much, we're producing too little, we're producing just about the right amount of weight. So we ultimately framed the problem as a multi-class classification problem. So that was our problem. And then we moved into the next phase, which was data acquisition. And I've actually got two phases on one slide here, data acquisition and modeling. So this is an IoT project. I mentioned things, connectivity, and data. The first thing we wanted to do was connect to the systems in question, the systems that were producing the data that would allow us to address that problem and to solve for that variability issue. So we connected the extruder device. It's a piece of manufacturing equipment connected to a manufacturing execution system that also had a weight measurement system, which was collecting weight on 15-minute intervals. It was a manual process of collecting weight, but that data was stored in a weight measurement system. And we connected to both of those systems and started pumping data up into the IoT hub. And so we had data from two different locations. We had data from the extruder, which contained information about everything that was happening in that extruder. So the torque on the motor, the amount of electricity being consumed, the temperature of the product at various steps as it moves through the extruder, the amount of torque on, there are actually two pumps in an extruder that push the mash of Twizzler through that nozzle. And something that happened that was interesting here, and this speaks again to the idea of iteration, was that we found that the data that we were getting from the extruder wasn't quite rich enough, that internal to the machine there were sensors for all the things that I've already mentioned, but we felt that temperature at the moment of extrusion was really very important and was not being captured. So we were able to actually add a simple sensor built onto a Raspberry Pi to collect just an additional sensor piece of information that helped increase the effectiveness of our models. But connecting into that data was crucial, and we actually fed both the weight data and the extruder data into Azure Machine Learning Studio, where we were able to join those two data sets together. There was some difficulty in making sure that the time element was properly accounted for, because it does take some time between when a given unit of Twizzlers is produced in the machine and when that same unit is actually measured on the weight measurement system. So creating that alignment was something that presented a challenge that we were able to work through. But we were able to solve that, and we had a data set that, 2 minutes? Oh man, I'm running out of time. Okay, I'll have to have to go a little bit faster. So you see, I get into a rabbit hole talking about this stuff. So what we were able to do was build a model that could relate everything that was taking place in that extruder. We did some feature engineering to the weight of the product. Is it too high? Is it too low? Is it just right? And once we proved out that model, we were able to deploy it as a machine learning API endpoint. And this is what our architecture looks like. It's a bit simplified, but we connected in to the extruder. We went through the IoT hub. We were able to use Stream Analytics to actually score live data coming in from the extruder, generate those predictions. Those predictions went into an event hub, so too high, too little, just right. And those were picked up by web jobs, sent back to the IoT hub. And this is crucial. Once we collected those predictions, those go back to the IoT hub and are translated into commands that go into the extruder, and the behavior is actually changed automatically. We call that closing the loop. So really fast, some key results. You can see in that top graph there, variability in the product before and after this intervention. So taking automated actions, when our model predicts the product's gonna be too heavy, we automatically slow the process down. If we predict it's gonna be too light, we're gonna speed the process up. Ultimately, that allowed Hershey to greatly reduce the amount of variability in the product, and ultimately save quite a lot of money just within that one process. But importantly, that whole procedure and the technologies we used, the architecture we used, the data science methodology is generally applicable. So it allows Hershey to understand how these types of projects are executed, the technology components that go into it, the process the components that go into it, the skills, the roles, the responsibilities, and that allows Hershey to take that same approach and the same technologies and apply it to other production lines, other scenarios, other use cases. So I'm out of time, but hopefully that was helpful. And I'll stick around a little bit. Thank you. I've got a few extra minutes if anybody wants to ask a question. Okay, thank you. Oh.
Any specific methodology when IoT projects are concerned, not just a generic machine learning?
Let me just say that I wish there were a TDSP for IoT projects.
Okay.
It's I would love that, but we don't have a defined kind of structured methodology like TDSP. But certainly elements of it apply. But we see IoT and machine learning as being very much
Right.
related.
I mean, ML prediction is one part of it, obviously, but IoT had a lot of other aspects from orchestrating the whole thing and managing the whole IoT landscape.